Hi, BMIS 270. This is Chapter 2, Part 2, and we'll focus today, or on this video, on, let's go find our PowerPoint, on secondary storage and operating systems. So that kind of bounces a little bit, but secondary storage initially, that covers your hard drives, tape devices, all of those sorts of non-volatile sorts of peripherals within your computer itself. That also covers flash drives or thumb drives, CDs, DVDs, Blu-rays. So secondary storage is non-volatile, has a greater capacity than primary storage, than memory does. So that means there's a greater economy. So you can buy more gigabytes or terabytes for a lesser amount of money than you can for main memory, for RAM. Now, the downside is considerably slower than memory, and that's why you have secondary storage that holds the operating system and applications. When you turn your computer on, that information is then loaded into main memory or RAM, which runs way faster. Okay. Also, read-write heads magnetize particles to represent data zeros and ones. So that's a regular, typical hard drive, not an SSD, but a regular like eSATA. And this head, or that platter, moves and spins. Let's see, I think 5,200, 5,600 maybe it is, 7,200 RPMs, revolutions per minute, and the faster ones are up around 16,000 revolutions per minute. So it runs very quickly. This little head moves around on the drive to actually pick out information. So all of this moves very quickly. There's only just a very fraction, small amount of space in between that head, that read-write arm head, and the platter itself. So even if a speck of dust gets in that sealed environment, it could cause a head crash. So pretty amazing how that works. Let's see. Let me go back one. Oh, I keep bouncing around. There. And of course, they can be internal and external. You have magnetic tapes, which are primarily for storing backups. Okay, so these tapes are really can store a lot of information. Maybe tens or hundreds of terabytes of information. So a terabyte is 1,000 gigabytes. So it can hold a lot of information, and it's really handy for saving all of your data. Like overnight, you'll do a backup. That backup of your entire system will go to tape, and then you pick that tape up, and then you'll take that tape off-site for storage, just in case something terrible would happen. You still have that storage. So that's a little bit about that. Next slide. Where are we at there? Okay. Also, for secondary storage, we have this picture. It talks about solid state drives as well. Storage area networks uses computer servers, distributed storage devices, and networks to tie everything together. So basically, you have a network device that's out there on your network with a lot of hard drives in it, and you just connect your computer to it over the network and then save everything out there on that. And this is kind of what an SSD drive, solid state drive, looks like. In comparison, a lot of chips, no moving parts. Moving parts here, no moving parts. Okay, now let me go back to our site. This Chapter 2, Secondary Storage, Part 1 of 3, Part 2 of 3, and Part 3 of 3, those are CompTIA videos, and they talk about secondary storage, the different kinds of secondary storage, and because CompTIA is providing certification within these areas, those videos are really very well done. So go to these links out there on YouTube, and that should be really beneficial. Now, input devices, I'm not going to touch hardly at all on that. Matter of fact, let's just don't. Now, portable computers, though, and some of your research and presentations will be about portable computers. So you have handheld computers, kind of in the way of the old PDA, and you still see some of that, but the smartphone has taken that market to a great extent. Notebooks, you have netbook computers, which are smaller than notebooks, and some students there at Helena College have netbooks, and they perform basic functions really well. Tablets, of course, you're looking at thinking about iPads. Nexus has a new tablet out. Google has a new tablet called Nexus out. I should say that. Kindle has a new tablet out. There's a new Samsung out that's pretty new anyway. So one of the projects is going to focus specifically on tablets along with tough books. So that would be really interesting to at least respond to that when that's out there. And then we have a thin client um, device that's fairly portable. It's actually a small computer that can tie onto your network, and it looks 2 or 3 times the size of your smartphone essentially, and it just acts as a pass-through device between your keyboard to the server. Next slide talks about multi-user computer systems. So you have your desktop. You have your desktop operating system. That could be Linux, could be Windows 7 and 8's on its way, or it could be the Mac OS, which I think Mountain Lion is the newest one. But then you start talking about servers. So with a server, that's used by many users to perform a specific task, such as running network or internet applications. And then that server, which you see like at Helena College, your Y drive is out there on that server. Your email is all held on one particular server. So that particular machine, all of you as students access it. Now a Blade server is the same idea, the same thing. However, it is more scalable, meaning that you can increase the performance of this particular server very easily. It'll house many computer motherboards. So basically, you just take this card and you slip it into the Blade server while it's running, and the OS and the hardware will go ahead and recognize that board, recognize the additional processor or memory, and configure it and use it on the fly. So it's really an interesting thing, and it's really scalable. If you need additional, like I said, if you need additional power, you can just upgrade very quickly. So it's incredibly scalable. Mainframes are large powerful computers shared by hundreds of concurrent users connected to the machine over a network. So a Blade server can be a mainframe. Okay, a regular, what we would call or think of as a desktop server, can be powerful enough that it can be considered a mainframe. And then supercomputers are the most powerful computers and fastest processing speeds. So that's really a step above. You have maybe as many as 256 CPUs tied together with terabytes of memory to actually run very large applications or enterprise applications, or other very specific sort of high-end applications on it. And again, some of your presentations will have that will cover this kind of information. Green computing, of course, efficient and environmentally responsible design, manufacture, operation, and disposal of IT-related products. Now, and just think about this as far as green is concerned. How much power, remember the old CRTs, the old cathode ray tube, large computer screens, okay, like the old TVs. Now think about the LEDs, LED computer screens. An LED computer screen will take just a fraction of the energy that a cathode ray or a CRT screen will take or will use. So at a point in time, not so many years ago, it was actually really beneficial for companies to go green in that they were putting in LCD screens in place of these CRT screens. And they would save, perhaps 75–80% on power costs alone. So that was considered green computing, and was certainly an acceptable way of upgrading your system so it will become more efficient and green. So let's see, and that enabled companies to lower their power-related costs. Next slide is operating systems, and of course, this is the software that actually runs your computer. It acts as the go-between between you and the peripheral devices, between the applications. When you're writing in Word, when you're typing in Word, that's an application. Your OS handles the printing, the managing of those printers, handles the network connectivity. So if you're using Google Docs, you can access the internet, and then the application, the browser, loads your doc. So this operating system is a set of programs that controls computer hardware and acts as the interface with an application program. Single computer, single users; single computer, multiple users. So this is an example of your desktop. Single computer, multiple users, that's an example of your server. Multiple computers with multiple users. That's a typical network server environment where you may have two servers that have the same programs on them, the same users on them. This creates redundancy, so if one goes down, one computer goes down, the other will keep running. And you can think about Amazon, for instance. If they had one single computer as a server, and they have hundreds or thousands, but if they had one and it went down, how much would that cost them? How much would that downtime cost them every single minute? So it pays to become redundant, and especially in that Amazon example. Let's see, and activities performed by the operating system. User interface and input output management. The keyboard, the mouse, the wireless stuff all ties into it. It manages system memory. We've talked about memory previously. It manages the processing tasks. So it works within the microprocessor or the CPU. It controls access to system resources. This is where you start to work on or think about security. Who has access to what? Also, which programs have access to which resources on the computer. Manages files, and you can think of your file manager for that. When you click on the start button and then computer, that's your file manager essentially. That's managing files. And then it handles the command-based or GUI-based interface. The GUI is a graphical user environment, so that is a GUI interface. Your command prompt, if I just type in CMD, this is what a command prompt looks like. Some of you have seen this, some of you haven't. I just type in commands to actually make that work. So you'll use that quite a bit in Linux. But a GUI is the graphical interface. The command-based is the text-driven, or command-driven. You'll use both of those. And then we have additional operating system tasks. Let's see, multitasking. So processors have become multitasking, can do more than one thing at once. Scalable. Scalability is a really important term. It is the ability of the computer to be able to handle an increasing number of concurrent users smoothly. So if we have 100 users on campus, the system there can handle 100 easily. Now, say we only buy a system that can handle 100. What happens when we get 1,000 students? Well, that system has to be scalable, and then it can move up and be able to hold or handle and work with those 1,000 users. Say we go to 5,000 users. That system, as is, needs to be able to move up and be able to handle that. That means that the operating system can handle it. You add additional memory, you add CPU, you add hard drive space, amongst other pieces of your network. So that's what scalability means, is the ability to move up. Let's see, network capability, that's the operating system handles that, and access to system resources. Let me scroll down. I think current operating systems, you have the Windows environments, you have the Apple environment, you have Linux, you have various flavors of Linux. Mountain Lion, I think, is the newest Apple environment. And I think that part 3, we're going to stop at this point, and I'm going to start at the work group operating systems and enterprise operating systems on part 3. So we've talked about operating systems. We've talked about secondary storage. There are videos out there, supplemental videos out there in Moodle that will really help further explain secondary storage. So thank you.